Kaku uncovers understanding into an astonishing disclosure. The James Webb Space Telescope has perceived an upsetting sign communicating from the Andromeda Galaxy for more than a century. How we could decipher Andromeda was by and large earthly, yet as of now, furnished with the James Webb Space Telescope, our perspectives are unequivocally moving. This new data has sent shock waves through established analysts. Anyway, what does this dazzling discovery tell us? And why is it making such a commotion among space specialists? Join us as we dig into the nuances of this revelation and investigate how it influences how we could decipher our bordering universe. Before we dive into the subtleties of the upsetting sign, it's important to see some context about the Andromeda Galaxy. By and large, the Andromeda Galaxy was the principal hint that our universe stretches out beyond the Milky Way. This discovery moved our understanding, highlighting that we may simply be a little piece of an immense universe. At first, the Milky Way was viewed as the entirety of the universe. Early cosmologists, utilizing restricted technology, were unable to separate the Milky Way into individual stars. This changed with Galileo Galilei in the 17th century. Using a telescope, he observed that the Milky Way was composed of various stars. This finding began to challenge the idea that the Milky Way was the universe's only galaxy. The real game-changer came with Edwin Hubble during the 1920s. Using the Hubble telescope, he saw distant objects beyond the Milky Way, identifying these as isolated galaxies, expanding our view of the universe. One of these galaxies was Andromeda, otherwise called M31. Its observation traces all the way back to the Persian stargazer Abd al-Rahman al-Sufi in the 10th century, who noted it without the help of adaptive technology. By the 20th century, technological advancements allowed stargazers to explore further. They understood that Andromeda was an unclear cloud with a massive universe of stars, like our Milky Way, yet situated around 2.537 million light-years away. The investigation of Andromeda has evolved significantly since then. Observations have moved from ground-based telescopes to space observatories like the Hubble, and as of now, the James Webb Space Telescope. Each new instrument has carried us closer to understanding Andromeda's true nature. Unraveling Andromeda's structure and organization assists cosmologists in delving deeper into the universe. It serves as a benchmark for our Milky Way, offering insights into galaxy development and advancement. The connection between the two galaxies is pivotal for understanding the fate of our Milky Way, especially since they are expected to crash in around 4 billion years. Recently, the James Webb Telescope has received an upsetting signal from the Andromeda Galaxy. But what does the latest signal tell us? The James Webb Telescope has brought new understanding and revelations. This remarkable instrument, endlessly better compared to its ancestors, has captured data from Andromeda that challenges past interpretations. The telescope's powerful sensors have identified surprising activity in Andromeda's core, differing significantly from previous observations. This has intrigued scientists around the world. The signal suggests fundamental processes are occurring inside the galaxy, possibly connected to its huge black hole or previously hidden inconsistencies. One key finding is the adjustment in Andromeda's mass. Prior estimates stated Andromeda was significantly larger than the Milky Way. However, new data suggests this gap may not be as large as previously thought. Updated estimations indicate Andromeda and the Milky Way are more similar in size, reshaping how we understand our own galaxy's place in the universe. Furthermore, the James Webb Telescope has provided clear images and spectra from Andromeda. These have revealed new star formations and chemical compositions within the galaxy. Such details are significant for understanding how galaxies evolve and what conditions might lead to life. Another significant discovery involves Andromeda's dynamic core. The data shows that the black hole at the center is more active than previously believed. This activity affects the surrounding area and may influence the galaxy's overall structure and future. The telescope's findings also address the mysterious dark matter. By studying the gravitational effects on Andromeda's stars, researchers can better understand how dark matter is distributed throughout the galaxy. This is crucial for addressing one of cosmology's greatest mysteries. What is dark matter, and how does it affect the universe? These new discoveries by the James Webb Telescope have prompted various studies. Scientists worldwide are analyzing the data to uncover more about Andromeda's secrets. Each finding helps piece together the galaxy's history and future, providing a clearer understanding of the universe's workings. Andromeda, our nearest galactic neighbor, has many unique features that interest cosmologists and set it apart from other galaxies. Firstly, Andromeda's size is immense. While estimates have changed, recent data suggests it spans around 220,000 light-years in diameter, making it one of the largest galaxies in the local group, much larger than the Milky Way. Its vast size adds to its mass, holding an estimated 1 trillion stars, surpassing the number in our own galaxy. Andromeda's structure is another focal point. It has a typical spiral shape but with a bulge. The galaxy contains a central bulge surrounded by rings of dust and gas, which are sites of active star formation. These features indicate a vibrant galaxy with ongoing processes that shape its appearance and evolution. The core of Andromeda is especially interesting due to the presence of a double nucleus, suggesting it may harbor a very massive black hole. This is similar to the Milky Way, but the nature and activity level of Andromeda's black hole provide important information for understanding these space objects. Andromeda is also surrounded by a halo of stellar material extending many thousands of light-years. This halo is composed of stars, planetary nebulae, and globular clusters, providing evidence of the galaxy's complex evolution and history. The globular clusters, in particular, are of significant interest. With more than 460 identified, they offer insights into the early stages of the universe's development and the dynamics of star clusters. Another unique aspect of Andromeda is its satellite galaxies. More than 20 smaller galaxies orbit Andromeda, some of which are being stripped of their stars and gas, contributing to Andromeda's growth. This process, known as galactic cannibalism, highlights the aggressive nature of galaxy development and provides a live example of how galaxies grow and interact over time. But how is the Andromeda Galaxy evolving, and what does its future hold? The evolution and future of the Andromeda Galaxy are subjects of significant interest and research in astronomy. One notable aspect of Andromeda's evolution is its potential transition from a spiral to a ring galaxy. Observations suggest changes in the pattern could lead to this intriguing form. Ring galaxies are rare and form under specific conditions, often after a collision or close encounter with another galaxy. If Andromeda is evolving into this structure, it indicates a history involving interactions with other galaxies. Andromeda's future is closely linked to its interaction with the Milky Way. Estimates predict that in around 4 billion years, Andromeda and the Milky Way will collide and merge. This event, while seemingly catastrophic, is a normal part of cosmic evolution. The collision won't involve direct impacts between stars due to the vast distances between them. However, the gravitational forces will reshape both galaxies. During the merger, gas and dust from both galaxies will interact, leading to new bursts of star formation. This burst of stellar creation will illuminate the merging galaxies, creating a unique and spectacular cosmic event. The collision will ultimately result in a single elliptical galaxy, a process common in the universe's history but novel in human terms. Given that our direct involvement in these events is highly unlikely, the very massive black holes at the centers of both galaxies are also expected to merge. This event could result in significant emissions of radiation as matter is consumed by the newly formed black hole. Focusing on this process provides insights into the life cycles of galaxies and the role of black holes in their development. So, what does the future of Andromeda and its expected merger with the Milky Way mean for the fate of our solar system? While it's unlikely that the solar system will be destroyed, its position and conditions could significantly change. This includes possible shifts in orbit or even ejection from the newly formed system. Understanding these processes helps scientists predict the outcomes of similar events elsewhere and provides context for the possible fate of our own planet. The study of Andromeda's evolution and future is about understanding the forces at play and the inevitable evolution of galaxies over billions of years. The expected merger between our galaxy and Andromeda raises significant questions about its impact on Earth's environment. It's essential to grasp that the vast distances between stars mean that actual star-on-star collisions are unlikely. However, the gravitational effects of such a merger would be substantial. The merger could disrupt the stable orbits of stars and potentially send many of them, including our Sun, into new trajectories. This change in position could have significant implications for Earth's climate. If Earth's distance from the Sun changes significantly, it could either heat up or cool down, depending on the direction of the change. A warmer climate could lead to melting ice caps and rising sea levels, while a cooler climate could trigger a new ice age. Moreover, the merger could lead to increased radiation reaching Earth. As the Milky Way and Andromeda's black holes approach each other, their interactions could accelerate particles to high energies, increasing the amount of cosmic radiation entering Earth's atmosphere. This increase in radiation could have detrimental effects on Earth's ecosystems, potentially leading to increased mutation rates in organisms and affecting biodiversity. Changes in Earth's orbit or axis could also disrupt the distribution of ecosystems across the globe. Species adapted to specific climate zones could find their habitats unsuitable, leading to shifts in biodiversity and ecosystem structures. Some species could thrive under these new conditions, while others could face extinction. Additionally, the